Hello everyone. So today let's solve the let's discuss the push-relabel algorithm, right? So previously we had discussed the Linux algorithm. So let's get into the definition part. So what does the definition part say here? The push-relabel algorithm, basically it's a method to compute the maximum flow in a flow network. So it's just a method to calculate the maximum flow in the flow network, right? Similar to the this one, what do we call Linux algorithm, Edmonds Karp algorithm, also Hopcroft algorithm, right? So this one I have to change this one I have misspelled here. This is Hopcroft actually, not Craft. This is fine. Uh, yeah, it maintains a pre-flow, right? It maintains a pre-flow. It may exceed the capacities temporarily, right? And it uses the push and relabel operations, right? It maintains the push and relabel operations to send flow from the source to the sink effectively. So that's what it does. So let's move on with the explanation part. Let's move on to the explanation part here. So pre-flow initialization part, let's discuss the same. So we'll start by sending the maximum possible flow, right? So we'll start by sending the maximum possible flow from the source to its neighbors, right? Source to its neighbors in the sense saturating outgoing edges, right? So we'll start by sending the maximum possible flows from the source, whatever the source is that we this one consider to its neighbors, right? So this is the first step. Next step is excess flow. When I say excess flow, we have to maintain an excess array or the excessive array here, where this one excess of u, this one edge u represents how much flow is at the node u, this one waiting to be pushed further, right? So it not this one, basically node u represents how much flow is at the node u waiting to be pushed further, right? So this is fine. Let's discuss about the push operation as well as the this one, what do we call relabel operation, along with the termination, right? So push operation, if a vertex u, right, if the node or the vertex u has excess flow and then adjacent vertex v has a lower height, then what we will do, we'll push as much flow as possible from node u to node v, nothing but the edge u to v, right? So this is fine. What does the relabel operation do here? If we cannot push flow, if we cannot push flow to any neighbor, all the neighbors are higher or edges are full. Suppose, let's consider that one, right? So we have to increase node use height to allow pushing later. So that's what we need to do. So this is relabel operation, right? So that is we call this, that is the reason we call this one as push relabel algorithm, right? So this is fine, I believe. Termination here, we will repeat push and relabel until no vertex, right? Until no vertex in the sense except source and the sink has excess flow, right? So this is fine. Yeah. Now push relabel, this is also one of the important points I wanted to discuss. Just listen to this. Push relabel is particularly efficient for the dense graphs and has better this one practical performance than Edmund Karp's Edmund's Karp and many case. So Linux algo is also better than Edmund's Karp, and this one push relabel algorithm is also better than Edmonds Karp algorithm. Just remember this one, right? While implementing, if you want to go with the intense optimization, instead of the Edmonds Karp, you can just go with the this one. What do we call? Instead of the Edmonds Karp or the Hopcroft Karp algorithm, you can just go with the Linux or the push relabel algorithm. Yeah. So this is fine, I believe. First, let's try to implement the exact same thing whatever we have discussed in the explanation in the form of algo or the code, right? So algorithm, let's make use of the Python programming language, man. Yeah. So now let's go with class here. So this one will be push relabel. Yeah, this is fine, man. The next part would be, let's go with the initialization part. So this one will be f init, nothing but the initialization part. So along with the self, let's go with n. Yeah. Now, so within the constructor part, let's go with the initialization. So I'll just go with here. Let me initialize n to n. Yeah. Next part is capacity. I'll just go with capacity here. Capacity. What's the capacity here? I'll just go with 0 here. N or underscore n range. I'll just go with a n here. This is fine. Yeah, this is nothing but the capacity matrix, man. Now let's go with the flow. flow, I'll just go with self dot flow here. This one, the same thing. Let me go with 0 into n for this one. Let me consider some underscore. That's enough. N range here. Same thing. N. This is fine. The next step is we have went with flow. Also, we have to go with the height as well as the axis, right? Axis flow at the vertices. Height is for the heights of the vertices. These two things. First, let's go with the height. So I'll just go with the height here. So this one, let me give 0 into n. Also, let me go with axis here. So this one, yeah, 0 into n. Yeah, this is fine, man. Now let's move on with a add edge, similar to the this one. What do we call the next algo, right? Let's move on with a add edge. So I'll just go with here def add edge. So let me go with self comma u. We have to consider nodes or the edge u to be u v, and also let me go with a cap here. This is fine. Yeah, cap is nothing but the capacity, man, not the cap actually, actual cap. So this is fine. I'll just go with self dot capacity. Let me go with capacity of u and v. Sorry. Yeah. Assign this one to the cap that we have considered in the parameter. Yeah. Next, let's go with a push. I'll just go with the push function or the method. I'll just go with def push. All I need is self nodes u and v respectively. Right. So this is fine. Let me go with push flow equals we have to go with min of this one excess of u actually excess of u. This is fine. And also capacity, let me type this one entirely, capacity of uv, we have to consider two nodes u and v, minus flow of this one, what do we call u and v respectively, nodes u and v respectively. This is fine, man. Now I'll just go with self dot flow. Let's consider flow here. U, let's consider V equals flow of UV plus this one, push flow. This one. Yeah. Again, let's go with self dot flow of V and U. V and U. So I'll just go with flow of VU minus push flow. Right. Let me go with the push flow. This is fine. Excess of U. Right. I'll just go with the excess of U plus excess of U minus push flow. This one. This is fine. Also, let me go with excess of V. So this will be excess of V. We go with excess of V plus push flow. Right. So this one will be push flow. This is fine. Finally, let's go with a print one. Yeah. Let me go with a print here just for the interactive purpose. What shall I give here? Let me go with a string interpolation. So I'll start with F here. This is fine. Let me go with pushed here. Let me pass push flow. This is fine. Yep, this is fine. From U as well as from U to V actually, not as well as from U to this is enough, I believe. Yeah, let me come out of this one entirely. Now we are done with the push function, man. So after pushing accordingly with the approach, what we need to go with basically, just give me a second here. After the push, we have to go with the relabel, I believe. Yeah. So I'll just go with the relabel method or the function here. Just go with u along with the cell. So within the relabel, let's consider min height here. I'll just go with the min height. So this will be float of infinity. Yeah, this is fine. I'll just go with for v in range, for v in range. So this one will be n This is fine. What we'll do, if capacity of UV, capacity of U and capacity of UV minus flow of UV, flow of UV, if it is greater than 0, then what we need to do? So min height, we have to assign this one to the min of, sorry, to assign this one to the min of, we have to consider min height along with the height of V actually. Yeah, height of, sorry, this is fine, man. Now let's do one thing. We have to assign the height of U to the this one, min height plus 1, right? So I can just write it on this way. Or let's do one thing. Yeah, I'll just go with height of U, height of U equals min height plus 1, plus 1. And final one here, let me go with the print statement here. This is fine. Let me make use of the string interpolation here. Relabel vertex. So this is fine. U to height. So I'll just go with self dot height of, we need to pass U, right? So this is fine. Yeah, this is fine. Uh, Entirely fine. Now we are done with this relabel function or the method. So we have to go with the discharge method as well. I'll just go with def discharge. So this is also fine. I'll just go with U. So now within the discharge function, I'll just go with while excess of U, if it is greater than 0, then what should I do? I'll just give here for V in range. For V in range, I'll just go with N here. Wait, this. Yeah, this is fine, man. Yeah, within the for loop, let's do one thing. Let's go with a if condition. If this one, capacity of UV, we have to consider. Let me type this one, capacity of UV, uh, capacity of UV minus flow of this one. What do we call? UV, capacity of UV minus flow of UV. Actually, if it is greater than 0, then we have to go with height, height of U, uh, the value of height of U, whatever we have considered, if it is equivalent to the this one, height of V actually, right? So I can just write it on this cell dot height of V less 1. So this is fine. Let me go with push of this one, U comma B. So this is fine. Let me go with break. This is fine. Yeah. Now let's do one thing. Yeah, this is fine. Let me go with else here. This is fine. We go with self relabel. I'll just give you a relabel of U. Relabel of U. This is fine. Yep. Now we are left with only one function, that is main function, nothing but maximum flow. We need to detect the maximum flow, right? So that is the reason we have written all the helper methods till now, right? So this is initialization part. So after initialization part, we have written add edge helper method or the function, push function, relabel function, discharge function. These are all the functions we have written to make use of it within the this one max flow or the main function or the main method, helper method, right? So I'll just go with the def max flow here. Max flow, this is fine. The name is relevant. I'll just go with S comma T. Yeah. Now let's do one thing. I'll just go with height of S. Let me assign this one to the N. Yep. Now, sorry. Let's do one thing. Let's write the for loop here. For V, vertex V in range. So in range N, right? So as we are going with the class, let me make use of the self. So we have to make use of the self everywhere, man. This is fine. If this one, what capacity of SV we are considering this time. So if capacity of S and V here, if it is greater than 0, then what we need to do? So let me assign certain things here. Just listen to this. So this one will be flow of S and V. Flow of S and V equals capacity of this one. We are assigning this one to the capacity of SV, right? So this is fine, man. Now flow of VS. Flow of V, this one. Flow of VS. So let me do one thing. This one. I'll just assign this one to negative self dot capacity, basically capacity here, capacity of same thing, S and V respectively. This time let me go with excess of V. Let me assign this one to the capacity of this one, SV, capacity of SV, right? So this is fine. Finally, I'll just go with excess of this one, S equals excess of S minus. We have to go with capacity of SV, I believe, again. Capacity of SV respectively, right? So now let's do one thing. Yeah, now let's do one thing. Let me assign active to. So this one I for I in range, for I in range. So this is fine. I for this one again for I in range is fine. Range n, right? We have to consider. So this will be self dot n is fine if I not equal to s and I not equal to t, and this one self dot excess of I, if it is greater than 0, then it is fine. If it is greater than 0, yeah, this is array itself, right? We are considering array itself. Yeah, 1 second. Yeah, this is fine. Let me go with while of active. So let me go with while of active here. So what are the things that we need to? There are certain things that we need to assign actually. So I'll just go with u equals. We are popping the this one active of this one. Let's go with the active dot pop of 0 actually. Yeah, this is fine, man. Yep. Now let me go with a variable here. Old excess. Let me assign this one to the excess of u. Right. So I'll just go with the excess of u. This is fine. Yeah. Now let's do one thing. I'll just go with, we have, let's call the discharge function here. I'll just go with discharge of, we need to pass u, right? The node u actually. We are discharging the node u. Also, what if the excess of u, the node u, if it is greater than 0, if the value is greater than 0, I'll just go with uh, excess here of u. If it is greater than 0, then what we need to do, I'll just go with active here dot append. This is also fine. Append of the node u. We are appending u to the active basically. And finally, we need to return what we need to return. We need to return sum actually. Sum. Uh, we have to pass here flow. Why this flow is not considering, man? It is not showing in the suggestions actually. Yes, so flow of S actually. S and I we have to consider, right? And also let's make use of the for loop here for I in range. this is fine. Range n basically. So this will be self dot n. This is fine. Yeah. So this is it for the algorithm. So this is it for the algorithm. We have went step by step, whatever we have discussed within the what do we call mm, explanation part. Now let's do one thing. Let me get the example usage from this one, man. What do we call Google? Let me get that one from the Google. Just give me a second here. So I'll just paste it over here. This is fine. Mm, we are considering four nodes actually, right here. This one push tree level of four we have given here 0, 1, 2, 3. So 0 to 3 actually 0, 1, 2, 3. We are considering four nodes, right? So 0 to 1, 0 to 2, 1 to 2, 1 to 3. This one 2 to 3 actually with the values 100, 100, 1, 100 as well as the 100, right? So let me represent the graph. So this one is 0 to 1, then 0 to 2 actually. I just write it over here 1 to 2 and 1 to 3. Let me write it over here and 2 to 3 as well. So yeah, 0 to 1, the value 100 we have, and 0 to 2 we have 100 as well here for this one, and 1 to 2 we have the value 1 actually for this one. Oh, sorry. So we are considering 0 to 2, right? 0 to 2, this one has to be 100. 1 to 2, it has to be 1 actually. 1 to 3, 100, this one. And 2 to 3, this one we have again 100, right? So this is fine. We are next we are printing just this one. We are making use of the print just for the interactive purpose. We have to get the maximum flow. We have called here max flow function as well, right? So from 0 to 3 we are considering. So before so this is this one, what do we call graph. You can just pause this one and have a look into it. Even if you want to come to this one later, you can just this one, come to this point of video and watch the graph. This is fine, man. Now I just want to explain certain things before running the code, right? So let me tell you one thing. Let me explain this one so we don't forget this one, right? So let me come to the capacity part here. So capacity and flow, whatever we have written, capacity as well as the flow, this one, right? Capacity, one second, capacity as well as the flow. So capacity and flow matrices, what it does, capacity and the flow matrices store the edge capacities and the current flow. Just remember this one. Height, whatever we have considered within the initialization, it represents the node height that is used to guide the pushers, right? Excess, whatever we have written, so this stores the excess flow at the nodes, right? So next let's come to the this one, add edge helper method or the function. Add edge function, this sets the capacity for an edge. Here we are going with a u, v and the capacity, right? So here we are setting the capacity for the particular edge, right? It sets the capacity for an edge. Next we are going with a push function. What we are doing within the push function, man, why it is needed? Because we are sending the flow from node u to node v, edge u to v, edge u to v, right? Edge u v basically. We are sending the flow from node U to node V and updating the excess and flow arrays both, right? Not only excess, and we are updating the excess along with the flow arrays, right? So just remember this one. Next, relabel. So this one I had explained. I didn't explain while writing, I believe. So let me tell you, relabel. What we are doing here, it increases the vertex's height when no push is possible. This itself we had discussed in the explanation part as well, right? So that's what this one relabel does. So what we are doing in the discharge, we know this. We are repeatedly pushing the flow or relabeling until u has no excess here. U has no excess, right? So this is fine. Next, we are going with a max flow, man. This is the main function, right? So what we are doing within the max flow, this initializes the preflow, sets the source height, and repeatedly discharges the active nodes accordingly with the this one. Uh, Accordingly with what we had discussed within the this one explanation, right? Finally, the active list, right? Finally, the active list, what it does basically, it ensures all the nodes with excess are processed. It ensures only all the nodes with the excess are processed. So here the output we need to get accordingly with the this one graph I had drawn earlier, right? So let me draw this one again, man. It will not take much time anyways. So this one is from 0 to 1 actually, right? Next we have from 0 to 2. This is fine. Next we have from 1 to 2, right? So this one 1 to 2. Next we have from 1 to 3. Let me draw this one like this. And next we have from 2 to 3. So we can consider this one. From 0 to 1 we have the value 100. From 0 to 2 we have the value again 100. From this one 1 to 2 we have the value 1. From 1 to 3 we have the value 100, and from 2 to 3 we have the value 100, right? So this is fine. So this is the graph. And so let's go with the explanation of the output. Yeah. So now what is the output first we need to get? So first what we are doing, we are pushing 100 from 0. We are pushing 100 from 0. This part we are pushing 100 from the 0. So first we get actually pushing 100 from 0 to 1, actually, sorry, pushing 100 from 0 to 1. So we are pushing 100 to this one, from 0 to 1, this part, right? So this is correct. Next we are pushing 100 from 0 to 2. So this itself, accordingly with the input itself we are going, right? We are pushing basically sorry, 100 from 0 to 2, right? So that's what we are printing here, maximum flow. And this one we are calling the maximum flow from 0 to 3. From 0 to 3 we have 4 nodes only. Push label of 4 we have considered, right? Nodes are actually 0, 1, 2 as well as the 3, right? So this is fine, I believe. So next one, the same thing, man. From 1 to 2 we have this one, right? So we are going with the only maximum flow, and the value that we have here is 100. We shouldn't consider this one, right? So again, this one pushed, this one maximum flow will be getting 100 actually from 1 to 3. So this one we are not considering as we are going with the maximum flow, right? So pushed at this one from 1 to 3 we have to get here, right? So this is fine. Finally pushed this one, what do we call, this is the max value again. So pushed 100 from basically 2 to 3, 2 to 3, right? So maximum flow here has to be 200. So maximum flow here has to be 200, right? So we are going from 0 to 1, 0 to 2, 1 to 3, and 2 to 3. So maximum flow, it has to be 200 here, right? So see, source 0, uh this one, initially the source 0 we are considering, right? So this one source 0 actually, this part, this one, let me go with the graph itself. Source 0 pushes 100 to 1 and 100 to 2, 100 to 1, 0 to 1 and 0 to 2. Source 0 pushes this one 100 to 1 and 2 respectively. Yeah. Now node 1, this one, node 1, or the node 1, this one, right? So let me write this one. Node 1 pushes this one 100 to 3, as well as this one 100 to 3, and node 2 pushes 100 to 3. This one node 2 pushes, sorry, node 2 pushes this one 100 to 3, 100 to 3, right? So node 1 and the node 2, node 1 pushes 100 to 3 and node 2 pushes 100 to 3. So the maximum flow from the source to sink, the maximum flow from, we are considering from source to sink, right? From source to sink is 100 plus 100, which will be 200. 100 plus 100, which will be 200. Basically this is the output that we need to get, maximum flow actually. Pushed 100 from 0 to 1, pushed 100 from 0 to 2, pushed 100 from 1 to 3, pushed 100 from 2 to 3, and maximum flow is 200 here. So this is what the output that we need to get here, right? So yeah, this is the output that we need to get here. And we have discussed the code as this one algorithm, as well as the code successfully, this one output as well, this one successfully. Let's do one thing, let's check the same, let's check whether we get the desired output or not. I'll give here control J, this is fine. Yeah, let me give here clear screen. I'll just give here Python followed by filename.py, right? So let me hit enter. We have one error. Let's clear this. What error we have? Push-Relabel object has no attribute add edge. So this is line number 78, man. What is the name we have given here? Add edge. We are having the add edge, man. What's the problem? One second. Oh, mostly indentation is wrong here, I believe. We have the correct name here, add edge. Yeah, everything I have pushed inside the this one. What do we call everything? We are every function we are calling within the constructor itself. See here indentation. Yeah, let me make this one to here as well. This one to here. Mm, This is fine. Let me remove this one. 1 second. Let it be here itself. Else, I think else we have to be within the same if, right? So this is fine. Now this is fine. 1 second. Yep, this one I would have formatted in single. This is fine, man. Yeah, now this is correct, I believe. Yeah, so this has to work correctly now. Do one thing. I'll just go with the same thing. Let me run the code now. So yeah, this one relabeled vertex 1 to height 1. This one relabeled vertex 1 to height 1 pushed 1 from 1 to 2. So this is fine. 99 from 1 to 3. We have to get 100, right? So somewhere something we have done wrong. Just give me a second. So there was an indentation mistake, man. Again, I have corrected the same thing. I didn't wanted to show that again. So this is fine. Clear screen. So let me run this one again. Yeah, now we are getting the correct one. See, uh, relabel vertex 1 to height 1, right? So pushed 1 from 1 to 2. So we were getting twice actually. Pushed 99 from 1 to 3. So this output is also correct, right? So this is also fine. So for what I have showed actually, we had considered this one, I believe, pushed 100 from 0 to 1, 0 to 2, 1 to 3, and 2 to 3, maximum flow 200. So at the end of the day, we have to get the maximum flow 200, and this version is also correct, right? This version is also correct. So this is showing relabeled vertex 1 to height 1. We have pushed 1 from 1 to 2. You can just check. So this is also correct. Push 99 from 1 to 3. So this is also correct. We are leaving 1. We are going from 1 to 3. We are leaving 1, right? So we'll consider 99, not the 100. Relabeled vertex 2 to height 1. Pushed 100 from 2 to 3. So this one, this is fine. This has to be. And relabeled vertex 2 to height 2. This is fine. Pushed 1. This is fine. Uh, pushed 1. Basically, what happens? Pushed 1 from 1 to 2. This is fine. Pushed 99 from 1 to 3, this is fine. We know pushed 100 from 2 to 3, this is also fine. Pushed 1 from 2 to 1, this is also fine. Relabeled vertex, you can just check the relabeled vertexes as well, or the vertices, right? So maximum flow, we are getting 200. This is also the correct version. Don't get confused. The maximum flow for both, we are getting 200, and this is also correct. So this is also the correct version for from what I have showed, right? Both yields us the right answer, and both the versions are correct, right? So just don't get confused here. This is fine. Now, yeah, we are done with the algorithm basically. We are getting the desired output, right? So let me summarize whatever we have learned so far. Just try to remember these 3 to 4 points, man. Yeah. First point here is push relabel algorithm. What it does, it maintains, again, it maintains preflow. It maintains preflow, and it uses, what it uses, push and relabel. Push and relabel operations, right? It uses push and relabel operations, right? So push relabel maintains preflow, and it uses push and relabel operations. It works well for the dense graph. Works well for the dense graphs actually, right? Works well for the dense graphs. So this is fine. The third one, unlike Edmonds Karp algorithm, it doesn't use BFS to find the augmenting path. So this one, even Dinix algorithm uses BFS and DFS. Edmonds Karp, this one uses BFS, this one and DFS. So this one doesn't use BFS, right? So this one doesn't use BFS, right? So you can see the code. Just now we have finished it on this one, writing the algorithm, right? So this one basically push relabel algorithm doesn't make use of the BFS, right, to find the augmenting paths. This is one of the advantages. Final flow is the sum of flows leaving the source. Final flow is nothing but the it is sum of the this one flows leaving the source, right? So this is some of the important points that I wanted to discuss with you guys. So now we are done with a push relabel algorithm, right? So we are done with a push relabel algorithm. So tomorrow we will be finishing off with the this one, the final two algorithms within the graph based algorithms, right? So here we had we just finished the push relabel algorithm. So next we will be going with a Eulerian path or the circuit algorithm, right? So Eulerian path or the circuit algorithm. Finally, one more algorithm is there after that. So that is nothing but Hamiltonian path or cycle algorithm. So these two algorithms we will be finishing it off tomorrow, right? Eulerian path or circuit and Hamiltonian path or cycle. These two algorithms we will be finishing it off tomorrow, right? So this is what I wanted to tell you, right? So these we will be finishing it off tomorrow. Finishing off it. Sorry, we'll be finishing this one tomorrow, man. Yeah, this is fine. Anyways, yeah. After that, so we'll be starting with a dynamic programming DP algorithm, some of the very important DP algorithms, right? So we are left with only two algorithms in the graph, nothing but Eulerian path or circuit algo, as well as the Hamiltonian path or cycle algorithm, right? So this is fine, I believe. For now, I hope this one, push relabel algorithm is completely clear, man. For now, this is it. Thanks for watching, guys.